Welcome to True Projects. In this video, we are going to explain about emEval 2020 task tool, multilingual offensive language identification in social media, OffensEval 2020. Introduction. The OLED dataset, which contains tweets annotated by various annotators to detect inappropriate language in social media posts, is described in the project. The project used multiple algorithms to identify offensive terms such as SVM, support vector machine, CNN, convolutional neural network, and emEval, and graded different annotator teams based on their accuracy. The dataset is utilized in this project to train machine learning algorithms such as random forest and SVM for foul language identification. The objective is to assess the accuracy of both algorithms, plot the findings, and create a system to anticipate offensive tweets in test data. To avoid memory concerns on typical laptops, training is performed on a subset of 5,000 tweets because of the enormous dataset. Objective. The project makes use of the OLED dataset, which has been annotated by numerous annotators to detect inappropriate language in social media text. Due to memory limits, the goal is to train machine learning algorithms, notably random forest and SVM support vector machine, on a subset of 5,000 tweets. The trained algorithms are then used to test data to predict offending tweets. The project's goal is to compare the accuracy of these algorithms, illustrate the data, and provide insights into the efficacy of both methods for detecting objectionable language in social media. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4 GB and above, hard disk 20 GB and above. In software requirements, we have Python IDE with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Upload OLED dataset. The OLED dataset is a dataset containing multilingual offensive language in social media. It consists of tweets categorized as offensive or not offensive. The data is usually provided in a structured format like a CSV file. Uploading the dataset involves loading the CSV file into your programming environment so that you can start working with the data. Second module is pre-processed dataset. Data pre-processing is a crucial step before training machine learning models. This involves tasks such as removing or handling special characters, emojis, and irrelevant data. Tokenization, splitting sentences into individual words or tokens. Lowercasing, converting all text to lowercase to ensure consistency. Removing stop words, common words that don't contribute much to the meaning. Lemmatization or stemming, reducing words to their base form, lemmas, to normalize the text. Handling missing data, dealing with null or missing values in the dataset. Third module is Apply Count Vectorizer. A count vectorizer is a text pre-processing step that converts a collection of test documents into a matrix of token counts. Each row in the matrix corresponds to a document and each column corresponds to a unique token word. The matrix indicates how many times each token appears in each document. This matrix is used to input for machine learning algorithms. Fourth module is Run SVM algorithm. Support vector machine is a popular classification algorithm. In the context of offensive language identification, an SVM can be trained to classify tweets as offensive or not offensive based on the features extracted from the count vectorized data. The algorithm finds a hyperplane that best separates the classes. Fifth module is Run Random Forest algorithm. Random forest is another classification algorithm that works by creating multiple decision trees and combining their outputs. Each tree is trained on a subset of the data and features, introducing randomness to the process. The ensemble of trees produces more robust and accurate predictions. Sixth module is Accuracy Comparison Graph. After training and evaluating both SVM support vector machine and random forest models, we can create a graph that visually represents the accuracy on the test data. This comparison helps us understand which algorithm performs better for the given task. Seventh module is Predict Offense Tweets from test data. Once the models are trained, we can use them to predict whether tweets from the test dataset are offensive or not. This is done by inputting the count vectorized representation of the test tweets into the trained models and obtaining the predictions. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. To implement this project, we have used OLED dataset. OLED dataset was prepared by multiple annotators to detect offensive words from social media tests. This dataset is trained with random forest and SVM algorithm. In this dataset, each tweet is associated with multiple labels assigned as subtask A, subtask B, and subtask C. Subtask A category contains labels as offensive 1 and not offensive 0. Subtask B category contains label as tin 1, UNT 2, and null 0. TIN is targeted insult and threats. UNT untargeted. Null is none. Subtask C category contains label as null 0, IND 1, GRP 2, and OTH 3. IND is individual insult, GRP is group, OTH is other insult. And this is the training dataset. So, training dataset, we can see each tweet contains associated class labels. In above screen, in each line, we can see values are separated with tab, and in second column, dataset contains tweet, and in third, fourth column, we can see class labels as off, UNT, and null. And in the test dataset, this is the test dataset. In the test dataset, we can see there is only tweets but not class labels. And after applying machine learning model, we can predict class labels. Test data, we have tweet columns but there is no class label, and ML will predict labels for above test data. And this is the model folder. This model folder contains the algorithm information. These files can be loaded into the project code during runtime to utilize the train models. This is the main code file. This is run.batch file. Instead of executing a project in the command line interface, we have created Windows batch file to execute the project. Double click on run.batch file. This is the graphical user interface which we have created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on upload OLED dataset to upload the dataset. Select the OLED training and open it. So here we can see that the dataset is loaded. Now click on pre-process dataset to remove stop words and special symbols. In above screen, we can see all tweets are cleaned from stop words and special symbols. Now click on apply count vectorizer to convert tweets into vector. In above screen, TF-IDF vector is generated and we can see all words are kept in vector column, and we can see each word frequency. And if word appear in that tweet, then count will put, else 0 will be put. In above screen, after building vector, we can see application read 5000 tweets, and in tweets it got 10,090 unique words. Now click on run SVM algorithm to train above vector with SVM and calculate accuracy on test data. After training SVM algorithm, we will get the SVM accuracy. Now click on run random forest algorithm to get its accuracy. After training random forest, we will get the accuracy of random forest. Now click on accuracy comparison graph to get the graph. So this is the comparison graph. X-axis represents the algorithm's name and Y-axis represents the accuracy value. So from this graph, we can say that random forest is performing well. Now close the graph. Click on predict offense tweets from test data and select the test data. Open it. In above screen, application displays test tweet and then displaying predicted request in square bracket. And in first tweet in selected test, we can see prediction result as tweet contains offensive, TIN and null. In above screen with each test tweet, we can see prediction result. And we can, if we scroll down, we can see all the prediction result. So here in the square bracket, we can see it is defined as not null null. And here it is defined as not tin null. So in this way, we can predict the test tweet. Now close the GUI, and the final conclusion of the project is The project replicates the use of the OLED dataset successfully. The dataset, which was created by a group of annotators, is used to detect inappropriate language in social media posting. Due to memory constraints, training random forest and SVM algorithms on a subset of 5,000 tweets result in good accuracy for both models. The labels connected with each tweet in subtask A, B, and C allow for multi-label classification. The project concludes that random forest and SVM are effective in spotting objectionable tweets from social media text, and the accuracy comparison graph visually represents the accuracy comparison. Thank you for watching the video.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.